Hi, and welcome to the COVID edition of eDesign. My name is Tinus, and I'll be teaching you this semester. I have many challenges, one of which is obviously that this is a practical module, and we're not going to have anything to touch. So this whole module will be based on simulation. Just before we start, a few things about myself. I am, like I said, Tinus. My official title is Associate Professor M.J. Boyson, but I don't care for titles, so you can call me Tinus. But the proviso is that we will respect one another, despite not using titles. Let's maintain respect. Just a bit about myself real quick. I'm from industry. I'm not a typical academic. I spent 10 years in industry. I worked for a company that made microsatellite, mostly remote sensing microsatellites. You might have heard of the Sunspace company. It originated from Stellenbosch University. But after about 5 years there, I went abroad. I worked for Rolls-Royce Aero Engines. I was the lead engineer on the Dreamliner engine. That's the 787 engine. And from there, I did some work with Pi Sherlock for Jaguar Land Rover and also for BMW Motorrad, BMW, the motorcycle department. So most of my experience that I will draw from is from that experience there. And I will try my best to make this module as relevant to you as is physically possible. I take a lot of pride in my work, you will see that. And I've put in a lot of thinking and a lot of time to ensure that I give you a module that's also useful to you. And something that you can take away, and despite the COVID challenges, that you can still feel you've learned something. So for me, that's really the essence. You have to walk away from here and have learned something. I can also tell you that the likelihood of not passing the module, you are unlikely to fail if you do your part. It's not an impossible module. We typically fail 5 to 10 students a year, but those are the students that don't keep up and don't ensure that they do their part. So as long as you do your part, you'll be fine. It is difficult, I'll admit that, but it's definitely doable. So let's talk about the project real quick. So this whole module is built around a physical project, and for this year what we're going to build is a heart rate monitor. And this heart rate monitor will do two things. The first thing is to measure temperature. So it's essentially a health monitor. Let's call it a health monitor. It measures the temperature of the patient. So for that part, that's the first part, you will develop the circuitry, the signal conditioning circuitry around taking the output from the sensor, amplifying a certain range of it, so the temperature sensor can go full range from -40 to 70, say. You will take a small range that's applicable to human temperatures, amplify that so that you have very high sensitivity and resolution around that temperature range, and filter it, so take away the noise. And then what we will test is that you are able to achieve that. And that's really what the first section is about. You'll see on Sunlearn, I've already posted that. You can start with it, have a ball, get it done. I've put the rubrics on there as well, so maybe let's quickly talk about that. What you will submit for each of the project phases is a report, and you'll complete a test, an online open book test, and then you'll also have to pass the functionality test. So for the report, the first report, I've put the rubric online, and for that report, you will be self-assessing. No, that's the wrong term. You'll do peer assessment. So each one of you will assess 2 other people's reports or 3 other people's reports, and you'll give it a mark based on the rubric that I've given you. For the test, that's obviously automatically assessed on Sunlearn, and then for the assignment functional test, you will submit your circuit diagram. And this circuit diagram we will simulate and then check that you meet the objectives that you've stated you will meet. One of the key elements of this module is to test, are you able to make this thing that performs the function that was set? So you start off with fairly loose requirements, or not specified, ill-defined is what they call it, ill-defined requirements, and you have to put a solution in place and ensure that it works. And you'll see the rubric is also split up into how well do you document, but then how well do you design, and how well do you assess that design. And those are broadly around the EXA outcomes. So as I said, 3 things for each submission. It's the report, it's the functional circuit diagram that you submit and we simulate and assess, and then the third thing is the test that's written on Sunlearn. For the second part of the project, so this is after, I think it's the second week in August, then you have to develop the heart rate sensor. So the heart rate sensor is pretty simple. You were supposed to build this physically, but that's not going to happen now. So it's a little clamp that sits on your finger. There's an LED that shines light, white light, into the bottom of the finger. At the top, there's a thermistor, a photoresistor, that's it, a photoresistor. And this photoresistor, or light-dependent resistor, LDR, it's also called, that LDR then changes resistance as the heart pumps blood through your finger. So those changes in the blood density you can pick up with that LDR. And the signal is obviously minute, it's really small, but that's the signal that you then have to process for the second part, and that's really the bulk of the work for the second part of the project. You'll assess that signal, or at least condition that signal, and then also amplify it so that we can read it with a microcontroller. There is a third part, but I'm still figuring out how to do that. You were supposed to use an Arduino or some microcontroller to interpret all these signals and to read the values and then display them on a computer. Now, obviously, that's not going to happen, so we're still developing and thinking about how to develop a microcontroller emulating environment so that you at least have the sense of reading a value, digitizing it, so converting the analog to digital, and then to send it over a serial port or some kind of a simulated serial port and display it. But we'll see how far we get. This is all pretty experimental. So as I said, I put a lot of time into this, and so did the Demi, the TA, I mean. So the TA is Michael Ritchie, and Michael Ritchie will be, he'll be setting up the tests, or many of the tests, helping with the assessments, especially the assessment of the simulations. And then we have a few demis as well. And the way that this module is going to work is I'll present videos to you, which you can watch at your own time. It's obviously best if you do it in the scheduled time, then you know it's done. And then we will have an interactive session during the practical, which is on a Friday afternoon, if I'm not mistaken. And during that time, you can ask questions. But I also want to encourage you to use the forum that I've put onto Sunlearn. Use that to engage with the fellow participants. So I've given each one of you individualized designs. So I've changed the sensor settings or the sensor specifications for each one of you. So you'll have to do your own work, but it's still very beneficial to at least discuss this with other people if you have questions. Often I have forgotten many of the things that you're going to learn now. So it's quite probable that I forget to say things that I need to tell you. So use the forum and use the discussions to learn from one another. The other things I think we'll pick up as we go on. I want to ensure you that I will try my level best, and even the people who are repeating this module will, I'm pretty sure, confirm this. I will try my level best to help you through this, and I will ensure that you have what you need to do this. And I don't mean I'll spoon feed you in any way. You will have to do the work. You will have to go through it on your own and figure out how to do it. But I'll put everything in place to allow you to do that if you do your part. And obviously this draws from all the engineering knowledge that you've acquired in the last 3-4 years, or 3 years rather. Okay, then the only other thing we need to discuss real quick is how the marks are allocated. So if you go to the study guides are also on Sunlearn, and in that study guide you will see there are 3 marks. It's one for the test for each one of the 3 assignments. It's the test, the report, and then the functional assessment of your simulation diagram. They then add up together with different ratios to give you your final mark. I want you to please go and have a careful look at that. It's very important. You need to achieve at least 50% for each one of those individual aspects to be able to pass the module. Moreover, your maximum mark that you can achieve is limited by the lowest one. So just go and have a look at the study guide. It's unfortunately a requirement because this is an exit level outcome module. It's important that you pass each one of those individual aspects. So it does happen from time to time. If somebody can't do one of the 3 aspects or don't have 50% for at least for at least every single aspect, that they will fail the module. So pay attention to that and be sure that you pass that. You're welcome to send me emails if you want, or as I said, use the forum on Sunlearn. And I think that's about me. That's a pretty long video, 12 minutes, but that's me for the first lecture. I look forward to seeing you on Friday, and I will put a link on Sunlearn of where this discussion is going to take place. I've not quite decided yet, but I will do so in quick time. Good luck with this module. I'm pretty sure you're going to sweat a lot, but it will be very rewarding, and you will walk away with knowledge that you don't have now. And what makes this module really special is the skills that you acquire now, you're going to use throughout your career and even in your personal life. I always use the example. One of the main reasons my wife loves me is because I can debug the children. And I think that's one of the most important skills you're going to learn in this module as well, to design, but then to find the problems, to reassess, to redesign, figure out what's going on and fix things. And hopefully you'll walk away with skills that you can transfer even if you end up dropping out of engineering, but please don't. Good.